This is 2021 paper 1 question 1. We have to figure out what k is. So what I do is I just multiply both sides by 2 plus 4i, or you could multiply it by the complex conjugate on the top and bottom to simplify that fraction. But since they give us an equation, we may as well use it. So 4 minus 2i will be the same as ki times 2 plus 4i. So that's just multiplying the 2 plus 4i up. And then we'll get 2ki when we multiply out the bracket, and then we'll have plus 4ki squared. And then that further simplifies to 2ki, and I squared is minus 1, so this is minus 4k. And then the left hand side is the same. So we can compare the real and imaginary parts because it's an identity. So 4 will be equal to minus 4k, and this tells us that k is equal to minus 1. And we can check that because if we use the imaginary parts, we should get the same answer. So if you look at the imaginary parts, minus 2i is 2ki, so that also means that k should be minus 1. Then we have to find the square root of this complex number. So you could use the Moivre's theorem, but the easier thing to do is say minus 5 plus 12i square root. That'll be equal to some complex number. We'll call it a plus bi, and a and b are reals. So we just have to figure out what a and b are. So we'll have that minus 5 plus 12i will be equal to, and we'll have a plus bi, the whole thing squared, which will be, just square out the bracket, you'll get a squared plus 2abi, and then we'll get plus b squared I squared when you do the last term, and then this part's all the same. And then that last term we can write as minus b squared because I squared is minus 1. Then we can group, so the real part is a squared minus b squared, and the imaginary part is 2ab multiplied by I, and then on the left side we have minus 5 plus 12i. So we can equate the real parts, and we get that minus 5 will be equal to a squared minus b squared, and equating the imaginary parts, we'll get that 12 is equal to 2ab, which tells us that ab is equal to 6, dividing both sides by 2. And now we have simultaneous equations, so I'm going to solve for a here and sub it into here. So I'm going to say that a will be equal to 6 divided by b. I'm going to sub that into this equation. So we'll have minus 5 is equal to, and then we're going to have 6 over b, the whole thing squared, minus b squared. And now to solve this, we can just square this. We get 36 divided by b squared minus b squared. Multiply everything by b squared. We'll get minus 5b squared is equal to 36 minus b to the power 4. I'll bring everything to the left side and say that b to the power 4 minus 5b squared minus 36 will be equal to 0. And the way that we can think of solving this is we have b squared, the whole thing squared, minus 5b squared minus 36 equals 0. So you can make a substitution if you want, or you can just solve this quadratic. So factors of 36, we can say minus 9 and plus 4. So we can write this as b squared minus 9 times b squared plus 4. If that's not okay, you could just say let x equals b squared, and then you can solve the quadratic, and then this part should be fine. Now, it's important, we're going to get 4 answers here if we're allowing complex answers, but it's important that a and b are real numbers because they're the coefficients here. If b was a complex number, then this bi part is meant to just be imaginary. If it was a complex number, bi would be complex itself. I mean, it should work out either way, but we don't really care about real solutions. So this second bracket won't yield any real solutions. So we'll just say that b squared minus 9 is equal to 0. And you might write this has no real solutions if you want. So then b is equal to plus or minus 3 when you factor this and solve, or bring the 9 to the other side square root. Okay, so if b is plus or minus 3, let's figure out what a is. Well, we know that a is 6 divided by b. So if b is equal to 3, so this is one option, b is equal to 3, and a will be equal to 6 over 3 is 2, and our second option, so then the complex number we get for that, we have to give our answers in the form a plus bi, so this will be 2 plus 3i, and then for the second answer, b equals minus 3, then a would be 6 divided by minus 3, and 6 divided by minus 3 is minus 2, so we'd have, and a is equal to minus 2, so we'd have minus 2 minus 3i. And this should make sense because this a plus bi, when we square it, we should get minus 5 plus 12i. And the reason for that is because this is kind of where we started. So we have a plus bi, the whole thing squared, should be minus 5 plus 12i. So if we square this, this is just the same as minus 1 times 2 plus 3i. So if we square this, the minus 1 goes away, and it's just going to be the exact same as this. So yeah, it makes sense that we got these two as our answers. And you can square those to make sure that they're correct as well. Then we have to use de Moivre's theorem to find the 3 roots of this. So the way that we can do that is, first of all, of course, to use de Moivre's theorem, we have to use polar form. So minus 8, that's just over here. So the angle is clearly pi, or I think I'll use degrees just because people tend to prefer degrees. So the angle is 180 degrees, and what's the distance from the origin? Well, it's just 8. So what we end up getting is we'll have 8 times cos 180 plus I sine 180. And you can verify that's true. Cos 180 will be -1, sine 180 will be 0, and then we're multiplying that by 8. So this works. And now we can apply De Moivre's theorem. So here's De Moivre's theorem, and basically what we have is this is the same as z cubed, right? So z cubed is -8, and this is the same as -8. So this is z cubed, so we're going to have to do the cube root on both sides to get our answers. Now the thing is, we're going to need 3 roots, right? So we have to do a little trick, of course, to figure this out. So what we have to do is we have to add on 360n. There's some good motivation for that, but basically, in short terms for the video, solution video, adding 360 to whatever angle doesn't actually change the angle, because if you add 360, it's just a full rotation. So this is completely valid to write as well. No matter what n is, this will always be equal to -8. So now to get z by itself, we can raise both sides to the power of a third. So power of a third, and we get power of a third. And then instead of having to figure out, well, what's the cube root of this big bracket, we can use De Moivre's theorem. So z will be equal to, and we can just take the modulus to the power, so we'll have 8 to the power of a third. And then we're going to have cos, and we just multiply the angle by the power. So we'll basically just end up having 180 plus 360n all divided by 3. And we'll have plus I sine, and then we'll have 180 plus 360n all divided by 3. Okay, so the cube root of 8, is just going to be 2. So we'll get 2 multiplied by, and we're going to have cos, and you can simplify that, you'll get 60 plus 120n, and then we have plus I sine, and then we have the same thing, 60 plus 120n, and then we can just do our answers. I don't know, yeah, we should give them the form a plus bi, so we'll take n equals 0 as the easiest one. So one answer is 2 times cos 60 plus I sine 60, n equals 1. We'll get 2 times cos 180 plus I sine 180, and this one should make sense, because remember that cos 180 is -1, I sine 80 is 0, so this will be 2 multiplied by -1, so it's -2, and when you cube -2, you get 8, well, -8, yeah, as we have here, so yeah, that makes sense. And then finally, we can do n equals 2, and we'll get 2 times, and then we'll end up having cos 300 plus I sine 300, and then you just need to write those in rectangular form. And what you should get for the first one is 1 plus root 3i. The second one should just be -2. Do they say in the form a plus bi? Yeah. So we should write -2 plus 0i just to be thorough. And then for the last one, we can write 1 minus the square root of 3i. And yeah, so that's good, and we're done.